Hi children, welcome to Active Learning. So this is the grade 10 chapter 5 where we will be discussing about operating systems. So if you haven't watched my previous videos, there's a separate playlist for grade 10 textbook. So please go to that and watch from the beginning, because from the chapter 1 I have done separate videos, and for a one chapter there will be like 4 to 5 like parts, because I want to make sure these videos are not very lengthy. Maximum it will go up to 40 to 60 minutes, right? So you can complete all these chapters and come to this one, or if you want directly you can start from here as well, but this is the 5th chapter for grade 10, right? So in this chapter we will be talking about operating systems, right? So first one, it's about introduction to the operating system, right? So a computer will have actually a few components, right? It has hardware, it has firmware, it has software, and it has liveware, right? There's another one which is not mentioned in your textbook. So what do you mean by hardware, right? Hardware is any physical component of the computer that you can touch, right? Tangible things which will have a definite shape, right? So we call them as hardware. For example, your keyboard, mouse, your monitor, right? Your hard disk, your speakers, your printers, your microphone, pen drives, all these storage devices, CDs, DVDs, all these are hardware, right? So it has a physical appearance, so you can touch it, right? Tangible, and it has a definite shape. So what is firmware? Firmware is actually like a collection of hardware and software. Right? There's a hardware. So within that hardware, there is like inbuilt kind of software to make sure that how that hardware is going to work. Right? So firmware is a collection of hardware and software. Right? For example, the booting instructions are stored in the ROM. So we call it as a firmware, because ROM is the read-only memory, and in that we have some booting instructions saved. So it's like software plus hardware. So we call it as a firmware, right? I will talk about booting a lot after some time, but for now, we'll go discussing about the other two components as well of a computer. Next one is the software, right? Software is not tangible. We cannot touch the software. So that's the main difference between hardware and software. Hardware you can touch and feel, but software you cannot touch and feel, right? So software is some set of instructions which will give to the computer. So the computer will work accordingly, right? And I told you there is another part in it, in this computer, right? We have hardware, firmware, software, and liveware. Liveware is the user, right? That means we who operate the computer, because without a human, the computer cannot do things itself, right? So there are automated machines and all, but there should be an user who will use the computer, right? So that is the part which is coming as the liveware, right? Okay. So then we'll talk more about this booting process, right? So do you have any idea what is this booting process? Now, I told you the booting instructions are stored in the ROM. So ROM, or read-only memory, is a non-volatile memory. What do you mean by non-volatile? That means even though you switch off the computer, even though there is no any power supply, the memory will have those information. It will be not gone, right? So all the instructions in the ROM will be there even you switch off the computer. Actually, these booting instructions are like given by the manufacturer itself. So when the computer is manufactured, these instructions are given in the ROM itself, right? So hope you have seen when the computer loads up there. Now I'm using mostly Windows. So you may have seen the Windows screen coming up, loading and all. right? So this is the booting process. When the user switch on the computer, you can see the loading process, and finally you can see nice user interface. So have you ever thought about how this happens, right? We'll see how it happens. Now, I told you all these instructions are in the ROM. So there are a few memories you have to have some idea. So ROM will have all the booting instructions. And our operating system is in our hard drive, right? Hard disk. So hard disk is also non-volatile memory. You know that when you switch off the computer, the things in the hard disk is not going to erase. It's there, right? So that is why when we work on something like a Word document, we have to save it. When you save it, it's in the hard disk or the hard drive. So then uh, later we can use it, right? So that is where the operating system is. But we know the CPU cannot directly access hard disk. So CPU is usually accessing its primary memory. What is its primary memory? That is the RAM. So CPU is always communicating with the RAM. Why? Because if you think about the hard disk, it's very slow. But CPU and the RAM, they are like with the same kind of speed, so they can easily work together, right? So problem is RAM is a volatile memory. That means when you switch off the computer, all the things in the RAM will gone. That's why when you start working in Word document, and if you don't save, that means it's currently in RAM. And if the computer is switched off, all those information will be lost. That's why we are asking you to save it in the hard disk. So RAM is a volatile memory. Now, what is this booting process means? Now I told you operating system is in the hard disk. So that should be loaded to the RAM. Then only CPU can continue working on. So this whole thing, we call it as booting, right? So when the user powers up, when the user gives the computer the power, so main thing, what happens is the CPU activates the BIOS. What is BIOS, right? Basic input output system, right? So this is actually kind of a software. What it basically do is like when the user first time, when the computer is loading, first time, at that time, this BIOS is a read-only program, right? So based on that, the computer will ask you to fill some things, like, for example, a date and time of the computer, right? And the booting order, right? CPU speed, fan speed, what is your default booting device, right? Those things you can configure in your CMOS. Here, that is mentioned later on, CMOS, complementary metal oxide semiconductor, right? So this is also volatile memory, but there is a supporting power given based on a CMOS battery. So that's a different story. So this CMOS will save all this information related to the BIOS thing. So if you, for the first time, when you configure your date time, if you configure your CPU speed, if you configure your what is your default booting device and all these things for the first time, then after that, CMOS is having it. Even though it's volatile, there's a supporting CMOS battery which will do the power supply. So we don't have to give it every day. Like when you switch on the computer every day, you don't have to give the date and time, right? So that is already saved, right? So now, based on the BIOS, right, basic input and output system, then all this information is stored in the CMOS. So next point, what they're telling is the first program activated is post power on self-test. Using the CMOS memory, this checks all the hardware and confirms that all are functioning properly. So BIOS setup will include the earlier things, earlier configurations, as I told. Then after that, this post will happen. So what is this post, right? So what this post is doing is like, so all this information are saved in the ROM. What are the programs to be done? Now BIOS was there, and then we have the post program. So post means what it does is this computer will check whether all the hardware parts are okay. Are they working? Is there any problem? Right? So for example, it will check the CPU. It will check the RAM. It will check your keyboard, your mouse. So each of these devices will be checked at the post. So if the post is successful, usually it will be a short beep sound. But if there are problems, there will be different kind of beep patterns to the user, because it can be some visual messages as well, or it can be audible beep sounds. So from these things, it will send some message to the user. There are some problems or it is successful, right? So if the post is successful, that means power on self-test. That means all your connected hardware is working fine, no issues, right? Then it will be the next step. After that, it reads MBR, Master Boot Record, in boot drive in accordance with the firmware bootstrap loader, which is provided by the computer manufacturer. Now, I told you in the ROM, all these things are there. We have BIOS, then we have post, then we have bootstrap loader. So what this bootstrap load is basically doing is it's telling the computer, okay, there's something called master boot record. Go there and get your OS, right? So master boot record means it's having some information. Usually master boot record is always at cylinder 0, head 0, sector 1. Right? So it is actually pointing the boot where this operating system is, right? So when the MBR is found, right, then it is telling, okay, operating system is in here, in this hard disk, this is the place. Because we cannot, the computer cannot search whole hard disk at each boot up. Right? So that is why we have this master boot record, so that it is easily found in the hard disk. So from the hard disk, it found the operating system. Then the computer loads the operating system in boot drive, right? Sometimes, usually it is in the hard disk. But do you know, sometimes we can boot up from pen drives, from CDs, from DVDs, like that. Yeah, yes. So that is why it is stored as boot drive. So your boot drive can be anything. Usually now, normally when we are working, it's the hard disk. But think now you have to do some repair to your operating system, or you have to do some partitioning, or you have to install another operating system, something like that. Then your boot drive is not your hard disk. It may be a pen drive. It can be a CD or something, right? So that is why from the boot drive, now this operating system is going to be loaded to the RAM, random access memory. Okay, now CPU can easily communicate with the RAM and work, isn't it? So once this is performed, now operating system is the captain, right? He's going to handle the computer, right? It's going to take the overall control of the computer. And initially you may have seen that loading screen, and then it will display a user interface to the user. So this whole process is called as booting, right? Basically what it does is the operating system, which is in the boot drive, it can be hard disk, it can be pen drive, it can be some optical drive. From there, it is loaded to the RAM. RAM means main memory or the primary memory where CPU can directly access. Hope this process is very clear. So in your exam papers, this can be tested, yeah. So please don't memorize each sentence. Please understand what really happens. Then it's really easy to answer the questions. Okay. Software, already I have told you, software is a set of instructions given to the computer to perform some activity using a computer. Set of instructions, right? And remember, software is not tangible, cannot touch, right? There is no any physical component, right? So when it comes to software, you can divide software into mainly two categories: system software and application software. So system software is a must to have, like in a computer. That is the one which is needed for the control, for the maintenance, and all these things. The whole computer should work based on this system software. But application software, it's not a must to have. Based on your user requirement, you can have different kind of application software. But system software, it's very important, right? Actually, under system software, we have basically three things: operating system, utility software, language translators, right? So I will I will talk about these things separately. And application software, there are so many examples you can think of, because based on the user requirement, it differs, right? Okay, under system software, first thing is the operating system. So that is our chapter actually. So here it's very small para, but don't worry, we have a huge chapter for this one, right? So operating system is basically providing the user and how user can interact with the hardware and software, right? So here it is telling operating system provides for the user to utilize the functions of a computer by managing hardware and software, right? So user cannot directly communicate with hardware anyway. So for that, the user needs operating system. If you see this picture, it's very clear. So this is our hardware: keyboard, mouse, projectors, anything, physical components, right? And this is the system software. So operating system is a must to have, because that is the one which provides a user interface where user can interact with hardware and software, right? And system software comes as a layer like this. Then only on top of it, you have application software. I will talk about application software, but this is the pattern, right? So what is utility software? Yes, operating system, yes, we have a big chapter, but utility software, this is the only place we are going to talk about. So utility software is also needed for managing and analyzing software in the computer, right? Remember, some students get this bit complicated to understand utility software, how it differ from application software, because basically utility software are like for the managing and analyzing the software itself, right? So based on the complexity, it's higher, right? Because utility software helps to manage resources of the computer. But when it comes to application software, it's based on the user requirement. What you want to do, for that you have some application software. Okay. So there are so many utility software, like two have been mentioned. One thing is antivirus software, right? When you work in the computer, there is a risk of getting viruses. Not only viruses, there are so many malware, right? Like worms, spyware, Trojan horse, so many things. So to protect your computer from that, right? When you plug an external hardware or a pen drive, or you insert a CD, or you click on an attachment from an email, you can get a virus. So to protect your computer from that, we can have antivirus software, right? For example, Kaspersky, right? There are licensed ones, there are open source ones, right? Licensed ones you have to pay. For the open source one, you can freely download. And disk formatting softwares. right? To prepare the to prepare the storage device in order to save files and folders, basically for the partitioning your hard disk and formatting. For those things, you can use disk formatting software, right? Even for backup softwares. And backup means what? Now, you normally for the personal work, we don't want to keep backups, but when it comes to enterprise level application developments and all these things, these data and all, it's very important. So you have to take backups, maybe daily, maybe hourly, maybe monthly, depend on your business context. So you have to take a backup. You have to take a copy into some place else. Sometimes physically also the place is different. Not that you take a copy from your C drive to D drive. That is small thing you personally you can do. But when it comes to business applications, they take the backup sometimes maybe from a region to another region. From, for example, thing like we have a Sri Lankan server and we'll take the backup into a US server like that. Okay. Then comes the language translators. So if you see in this diagram, there are three things coming under language translators: assemblers, compilers, and interpreters. So what is a language translator? Forget about computer. What is a normal language translator will do? Now think there's a Sinhala person and there's a French person. So two cannot talk together with each other. So there is in the middle, there's a language translator. So Sinhala person will talk, then the translator will translate that to French and will tell it to the French person. Similarly, what French person is telling, it can be translated to Sinhala and will be told to the Sinhala person. So that is what the language translator will do. Similarly, a computer program. Now we know software is made up by set of instructions, right? So these instructions are in the earlier days. Now, if you learn about programming, develop how this evolved, initially people wrote instructions or the software using machine language itself, right? Now, computer understand that, right? Because computer understand only the machine language, ones and zeros, ones and zeros. So initially in the early days, yes, people use machine language itself to write the programs. Then no need of a language translator. But later on, people were using assembly language. Please read about this, how this programming language evolved, right? Then came the assembly language. So there we have some like small kind of English words, but it's also a bit hard for the programmers to write because it's with the registry level and all. So we had this assembly language. So to language translation from assembly language to machine language, we had used assemblers. Nowadays, we are using very high level programming languages like C#, Java, Pascal, Python. In web area, we have so many other languages, right? So these high level languages are very close to human languages. Now, if you learn this now in grade 11, you are learning. But after that, when you do real programming and all, like now, what I'm doing is basically .NET. So C# is my main language I'm using. So those are very close to human languages, right? Like English, right? So these high level languages needed to be translated to machine language, right? That is why we have another two, compiler and interpreter. Actually, these two are doing this translation in a different way, but the concept is same. Assembler, compiler, and interpreter, all three needed because the high level programming language should be translated to the machine language. So what's the difference between compiler and interpreter? Compiler, the whole source code. Source code means what the programmer writes. That is like, look like very much like English. So that the source code will be fully translated to machine language using a compiler. But when it comes to interpreter, each line by line of the source code will be translated to the machine code. So this is not very important for your level, but just have some idea. Okay. Okay, then now this is the one part, system software, right? System software, we had operating system, we have utility software, and we have language translators. The next category is application software. So application software means software which are needed to fulfill user requirements. For example, you want to prepare a letter or an assignment or a report. So you will be using word processing software like Microsoft Word. You want to do some budgeting, budget applications, or you want to do some mathematical thing, or you want to draw some graphs, right? So user has some requirement like that. Then you can use some kind of a spreadsheet application like Microsoft Excel, right? And you want to play a game, right? There are so many computer games, can be like a desktop application or online games are there. And then web browsers. To search internet, you need to search internet. For that, definitely you need a web browser like Google Chrome, Opera, Safari, Microsoft Edge, Microsoft Explorer, anything like that. Web browsers are needed. We have audio editing softwares like Audacity. We have video editing softwares like OpenShot. We have graphic uh, designing or graphic editing softwares like Photoshop. See, so many application softwares. Same thing like in our mobile phones, we have app, same concept, Google Maps, those kind of Facebook app and all these things. These are also actually application software which will be run on top of an operating system. So these are not a must to have. If you want, you can uninstall, no worries, right? Next part, importance of operating system. So I told you without an operating system, computer cannot work. So operating system is the one which facilitates the interaction between the user and the hardware, right? So operating system is doing so many things, right? It will do hardware management, software management, memory management, network management, security management, file management, right? So many things are done by the operating system. Right? So the operating system will provide the instructions for installation and management of application software as well. Right? So it's like the captain of the team. Right? And operating system will manage all the hardware. I told you input, output, computer memory, right? So the operating system is the sole software which manages the whole computer system. So that's why without an operating system, a computer cannot work. So see how these interactions are happening. We have hardware, we have user. So human user cannot directly access the hardware. It goes through the operating system. See, operating system should be there. User will interact with the operating system, and based on that, it will interact with the hardware. User cannot directly contact or interact with the hardware, right? And user cannot directly interact with other system softwares as well, like the language translators and utility software. But user can, yes, interact with the operating system as well as user can interact with the application softwares like word processing software, spreadsheet applications, web browsers, computer games, all these things. So application softwares are also contacting or interacting with the OS. Then only OS talk with the hardware and other system software and communicate back. Hope these arrows are very clear. Understood? Okay, last part we are going to talk in this video. So it's about introduction of several operating systems. So we have so many operating systems, but Microsoft Windows is the most popular one, I guess. I'm using that, but it depends. But I think most popular one is this one, right? So this is introduced by Microsoft, and it's a proprietary software. What do you mean by proprietary? That means you have to pay for the software license. In Sri Lanka, yes, most of the people are not paying, right? They will use a cracked version or some copy, or they do various things. They never pay for the license, but that's not the correct way, especially when it comes to the enterprise. If you're an enterprise level person, you have to pay this license. Otherwise, it's illegal, right? Because this is a proprietary software, right? So that is why it's a you have to pay and get it. And but this is the, I think, most popular one, and it is having a lot of editions, right? We have Windows XP, Vista 7, Windows 7, Windows 8, Windows 10. Now it's Windows 11 also have come, right? So there are so many versions, right? And even Windows mobile version is also there for the smartphones. And there's a separate version for the servers as Microsoft Windows Server, right? So remember, as this is a proprietary software, the code, the source code is not available. Nobody can introduce any feature for this. It's totally owned by Microsoft. If Microsoft decide to do something, then only it is there, right? Uh, Apple Mac operating system. This is also a proprietary one, Mac operating system, which was developed by Apple Incorporation, right? So this is also proprietary. That means you have to pay for the license, right? And this operating system can be installed only on Apple computers, right? Ubuntu. So Linux, there's a Linux called operating system, and Ubuntu is another operating system which was developed based on Linux, right? So this is not a proprietary one. That means you don't have to pay for the license. It's free of charge. We call it as free and open source. Now see, you can easily download, you can go to this link and you can download and use it. You don't have to pay for license. It's free anyway. And remember, the source code is available for you. So if you are a really smart guy who are with these developments and all, so you can change the features. You can develop your own thing, for example, this Hantana Linux. So this is developed based on the Linux operating system, right? So similarly, you can change the source code. There is a separate open source community which will handle this. So this code is freely available, not like Windows, right? And then comes the Android operating system, right? This was developed by Google, and it's for the mobile devices. This is also very popular operating system, and it's also free and open source. Most of these Samsung and all these phones are having Android operating system, right? Okay, so we learned few operating systems as well. So that's the only thing I'm going to cover in this part. There will be few more videos for this chapter. So if you haven't still subscribed my channel, please do subscribe, and please press the bell notification as well, so you get the notifications when I upload new videos. And please do comment if you learn something, if you got 100 out of 100, or if you get some good marks in your assignments. Please share them, because I know a lot of kids are sharing, so it's really encouraging. And if you have problems, yes, please ask. I will try my best to answer all these things, all the questions you have. And yes, please don't ask to do these videos I'm doing. Yeah, there will be a bit delay, because I have to cover few chapters here from other grades as well. And yes, I will cover all the chapters as soon as possible, right? So please share these videos as well. Thank you very much.